is Kylie Fril G. Collado from BSE E2C, and today I'll be solving a beta function. Ganito mag-solve ng beta function. First, sulat muna natin yung formula for beta function. B of x, y equals 2 integral of pi over 2, 0, sine sine squared x minus 1 times cosine over 2y minus 1 data data. Ngayon, apply natin itong mga value na to. Ito, value to ng x, and ito, value ng y. Apply natin siya ngayon dito sa ating formula. 2 integral of pi over 2, 0, sine. Ito, again, apply natin itong value na to dito. 9 over 2 times 2 minus 1 data times cosine. Ito natin yung y, 7 over 2 times 2 minus 1 data data. Ayan. Isunod na po is 2 integral of pi over 2, 0, sine. Cancel natin ito. Then, 9 minus 1 equals 8 data. Saka sine, cosine, 7 minus 1 equals 6 data data. Ito na yung nakuha natin sa formula na to. Ngayon, express natin siya using gamma function. Since 2 integral of pi over 2, 0, sine x data times cosine y data. Express natin siya using gamma function. Formula for gamma function. Gamma of x, gamma of y, gamma of y over gamma of x plus y. Express natin siya. Gamma x plus 1, gamma y plus 1 over x plus y plus 2 over 2. natin to. Value pala ng x natin ay 8. And yung y ito 6. Apply natin siya dito. Magiging gamma 8 plus 1 gamma y plus 1. No. 6 plus 1. 6 plus 1 over 2 gamma 8 plus 6 plus 2 over 2. Yan. May matitiran to. Panin natin ito. Cancel. Yan. Giging 9. Lagay yung over 2. 9 over 2 gamma 7 over 2 over 16. 2. Since whole number siya, natin 8 gamma of 8. Ayan, i-factorial natin siya using this formula n minus 1. Sunod, factorial na natin itong gamma 9 over 2. 9 over 2 is 4.5. 4.5 minus 1 equals 3.5, which is 7 over 2. Sunod, 3.5 minus 1 ay 5 over 2. 2.5 minus 1 ay 3 over 2. Then 1.5 minus 1 is 0.5, which is 1 over 2 times gamma of 5. Sunod, 7. 3.5 minus 1 equals 2.5, which is 5 over 2. Then, ganun ulit, 2.5 minus 1 equals 1.5, which is 3 over 2. Then, 1.5 minus 1 equals 0.5, which is 1 over 2 times gamma of 5. Factorial din natin 8 minus 1, 7. 7 minus 1, 6. 6 minus 1, 5. 5 minus 1, 4. 4 minus 1, 3. Times 2 minus 1. Ay, 3 minus 1 is 2. Times 2 minus 1. 1. Cancel. Cancel natin ito. Then ito. Then ito. Meron pa? Meron pa ba? Ay, meron pa. Ito. Since ang 6 ay 3 times 2, pwede natin siya i-cancel dito. Kaya ang mga natira, kuhanin natin yung mga natira. Ang mga natira ay 5 over 2 times 1 over 2. 5. Sa baba is 2 times 4 times 2. Ano natin sagot? Calculate natin. ganun lang natin kuhanin yung sagot dito using these three formulas dito sa beta function. Ito yung first formula or first application. Ito. And then yung second application or second formula naman, ito yung gamma. And lastly, yung third application or formula, ito. Para makuha natin itong sagot na ito. Ganun lang kadali kuhanin nyo or i-evaluate dito sa beta function.
Other special functions. Many special functions are of importance in science and engineering. Some of these are given in the following list. Other will be considered in later chapters. Number 1 is error function or ERF of x is equal to 2 over square root of pi times integral of 0 from 0 to x of e raised to negative u squared du is equal to 1 minus 2 over square root of pi times integral of x from x to infinity e raised to negative u squared du. Number 2 is exponential integral. EI of x is equal to integral from x to infinity of e raised to negative u over u du. Number 3 is sine integral. SI of x is equal to integral from 0 to x sine u over u du is equal to pi over 2 minus pi minus integral from x to infinity sine u over u du. Number 4 is cosine integral or CI of x is equal to integral from x to infinity cosine u over u du. Number 5 is Fresnel sine integral or S of x is equal to square root of 2 over pi times integral from 0 to x sine u squared du equal to minus 1 minus square root of 2 over pi times integral from 0 to x sine u squared du. Number 6 is Fresnel cosine integral C of x is equal to square root of 2 over pi times integral from 0 to x cosine u squared du is equal to 1 minus square root of 2 over pi times integral from x to infinity cosine u squared du. Then example of error function. Formula ERF of x is equal to 2 over square root of pi times the integral from 0 to x of e raised to u squared du is equal to 1 minus 2 over square root of pi times integral from x to infinity of e raised to u negative u squared du. Dito sa example na to, now we have integral of ERF x dx where ERF of x is equal to 2 over pi squared times the integral from 0 to x e raised to negative t squared dt. So dito, sa part na to, pwede natin siya i-differentiate by doing the integration by part. Pero bago natin i-differentiate, di ba? Kapag nag-integrate tayo by parts, yung one part dapat may differentiate muna same as the other part. So, punta tayo ngayon sa DI setup dito. O DI method. So, naglagay ako ng plus minus sign dito. Tapos nilagay ko ERF of X sa tapat ng D. Bakit hindi sa I? Kasi kapag nilagay ko sa tapat ng I, yung ERF of X, parang kinopya ko lang yung original question. So, nilagay ko yung 1 sa tapat ng I, then binaba ko rin yung negative 2 over square root of pi e raised to negative x squared kasi constant multiple naman siya. Di ko na nilagay yung nakasamang integral kasi yung integral at derivative makaka-cancel na. So, the integral of 1 is x. Then, ngayon, punta tayo sa ERF of x times x. So, dito, lalabas yung first part ng sagot. So, write down lang. So, this is equal to x times ERF of x minus a. Then, para sa second integral, dito tayo titingin sa naka-broken line. Dito. Na naka-box. So, alam naman natin na the product of that is integral also. So, write down lang yung negative integral. Then, lagay yung tabi yung x. Then, e to negative integral, then negative x squared dx. So, since constant multiple siya, lagay lang natin yung 2 over 2 over square root of pi sa unahan. So, double na siya ngayon. Doable na. So, kung titingnan natin, di ba dapat 2 squared dito? 2 over square root of pi yan. Naging 1 over square root pi siya kasi yung derivative ng x squared is negative 2x kaya naging negative 1 over square root of pi times integral of 2x e raised to negative x squared dx. So next, write down lang natin ulit yung ERF, yung x ERF of x plus yung 1/2 square root of pi. Dito pala, bakit siya naging plus? Di ba dito minus? Kasi makaka-cancel na yung integral of 2x. Integral of x of 2x. So yun yung sagot. Nawala lang to. Then copyright down lang plus c. So yung final answer is x ERF of x plus 1 over square root of pi of e raised to negative x squared plus c. Next example is exponential function. Ito, exponential integral. Formula, ito, ei of x equal to integral from x to infinity e raised to negative u over u dx. So dito yung example, ito yung tanong. Ang integral 2x plus 7 e raised to x squared plus 7x dx. So, for applying integration by substitution method, tawagin natin nun, u substitution. Una, kailangan muna natin ma-identify yung section within the integral sa bagong variable. Di ba tinatawag ito yung like u du. So yung nakapagka pinalitan, di ba mas mapapadali yung pag-integrate. So as we can see that x squared plus 7x is okay na gamitin sa pag-substitute. So u is equal to x squared plus 7x. Ngayon, in order to rewrite dx in terms of du, kailangan muna natin hanapin yung derivative ng u. Kailangan i-calculate yung du. Magagawa natin yan by deriving the equation above. Du is equal to 2x plus 7 dx. Then, i-isolate lang yung dx. So, sa previous equation, so du du over 2x plus 7 is equal to dx. Substituting u saka dx in the integral. Then, simplify the fraction e raised to u over 2x plus 7 over 2x plus 7 by 2x plus 7. Kaya naging ito, integral of e raised to u du. Tapos, replace lang yung u sa value na naka-assign kanina na x squared plus 7x. Kaya naging e raised to x squared plus 7x. Then, take note lang din na dahil yung sinusolve is indefinite integral, lagyan lang natin ng constant integration c. Kaya, nakuha ang sagot, ito, e raised to x squared plus 7x plus c. Yun lang.
Special functions and asymptotic expansions. So A, prove that if x is greater than 0 and p is greater than 0, then ip is equals to integral from x to infinity e raised to negative u over u raised to p du. So it is equals from Sn sub x plus Rn sub x, where Sn sub x is equals to the e raised to negative x, 1 over x raised to p minus p raised over x raised to p plus 1 plus p times p plus 1 over x raised to p plus 2. Then minus, and then so on, so on. So this is, we can say that this is a series. So, and then if we continue, so negative 1 raised to n, then p times p plus 1, then series p plus n over x raised to p plus n. So sa Rn naman, sub Rn sub x is equals to the negative 1 raised to n plus 1 p times p plus 1. So series again. So p plus n. Then integral from x to infinity e raised to u over u p raised to p plus n plus 1 du. So B, prove that the limit of x to infinity as infinity. So integral x from infinity. So e raised to negative u over u raised to p du minus Sn sub x, then xn is equals to the limit of x to as infinity, x infinity it is equals to the limit x to infinity xn, then the magnitude of Rn sub x is equals to 0. So, itong naka-bracket nito guys, this is simply is equals the magnitude of Rn sub x. So, ayun lang siya. So, by solution, ito yung makukuha nyo, equals to 0. Explain the significance of the result in B. So integrating by parts, we have IP is equals to the integral from x to infinity e raised to u over u raised to p du. So it is equals to the e raised to negative x over x raised to p. So pinalitan lang natin yung u. So minus p, then integral from x to infinity e minus u over u raised to p plus 1 du. So dito nag-integrating by parts tayo, kaya ito nakuha natin. So this will be equals to the e raised to negative x over x raised to p minus p ip plus 1. So we know that itong integral from x to infinity e raised to negative u over u p raised to p plus 1 du, it is equals the ip. So ayun na, papalitan lang natin ip. So ayun. So similarly, ip plus 1 is equals to the e raised to negative x over x raised to p plus 1 minus p plus 1 times ip plus 2. So that ip is equals to e negative x raised over x raised to p minus p, then open close bracket. So e minus x, or e raised to negative x over x raised to p plus 1 minus p plus 1 times ip plus 2. So it is equals to the e raised to negative x equal x raised to p minus p e raised to negative px negative x over x raised to p plus 1 plus p times p plus 1 times ip plus 2. So kapag kasunod natin to, itong similarly ito, kapag kasunod natin to, so ito makukuha nating sagot. So by continuing this manner, required result follows. So magnitude of Rn is equals to the p times p plus 1, then series ng product. So p plus 1, and then integral from x to infinity. So e raised to negative u over u raised to p plus n plus 1 du. So it is less than or equals to the p times p plus 1, then series p plus 1 p plus n. So integral from x to infinity. So e raised to negative u over x raised to p plus n plus 1 du. So kapag kainan natin to, so we are equal then sa p times p plus 1, then series p plus n, so on over x raised to p plus n plus 1. So by continuing, so since integral from x to infinity, so e raised to negative u du less than or equal to the integral from 0 to infinity e raised to negative u du is equals to 1. So thus, the limit of x to infinity xn is the magnitude of Rn sub x is less than or equal to the limit of x to infinity p times p plus 1, and so on, p plus n over x raised to p plus n is equals to 0. So because of the result in B, we can say that the integral from x to infinity e raised to negative u over u raised to p du is tilde. Itong sign na to is tilde. Kung hindi ako nagkakamali, tilde yon. So, tilde. Tama ba, tilde? Well, tilde, basta ba na kayo sa. So, e raised to negative x. Then, bracket, 1 over x raised to p minus p over x raised to p plus 1 plus p again times p plus 1 over x p plus 2. So, kung naguguluhan kayo dito, guys, ito yung series niya, ganun. So, series. So, katulad ng 1 plus 1, ganun. 1 magiging 2, magiging 3. So, parang ganun lang din yun. So, the series on the right is the asymptotic expansion of the function on the left. So, ito yung integral from x to infinity e raised to u over u raised to p du. This is yung, so itong nasa kanan, ito yung kanyang asymptotic expansion. Yung series, yung naka-series. So let's proceed this. Show that, ito na, example na tayo. Show that so what is this r? So r functions sub x. So tilde 1 minus e raised to negative x squared over the square root of pi. So 1 over x. So 1 over x. So minus 1 over 2x raised to 3 since this. So tuloy-tuloy lang natin. So 1 times 3 over 2 raised to 2x to the raised to 5. So minus 1 times 3 times 5 over 2 raised to 3 x raised to 7 plus so on and so forth. So we have r function sub x is equals to the 2 over square root of pi integral from 0 to x. So e raised to negative v squared dv is equals to the 1 over square root of pi. Then integral from 0 to 0 to x squared. So u raised to negative 1/2 e raised to negative u du. So for so magiging ganito yung sagot niya. So 1 minus 1 over square root of pi integral from x squared to infinity. Kasi nga, nag-x squared na tayo dito. So, u raised to negative 1/2 e raised to negative u du. So now from the equation 1 of problem 9.26, we have on letting p is 1/2 and replacing x by x squared. So therefore, yung square root of integral from x squared to infinity. So ito yun. So u raised to negative 1/2 e raised to negative u du. So tilde. So dito nakalagay is by replacing by x squared. So e. So raised to negative x squared. And then yung kanyang asymptotic expansion, which is the 1 over x minus 1 over 2x to the third plus 1 times 3 over 2 raised to 2 x raised to 5 minus 1 times 3 times 5 over 2 raised to 3 x raised to 7 plus so on and so forth. So which gives the request result. So for more example, it will be continued by my group mates. So yun. So here are the other examples of gamma functions. So example number 1. So finding the or evaluate the gamma of 6 over 2 gamma of 3 is equals to the 5 factorial then 2 times 2 factorials. So ganito lang ang pagsusolve. So we are here the formula of gamma of n is equals to n minus 1 factorial. Kaya yung 6 na yun, gamma of 6 is magiging 5 factorial since n is 6 minus 1, so 5 factorial. Then 2 factorial, gamma of 3 is 2 factorial. So, ayun. So, solving for factorial is 5 times 4 times 2 times 1. Then 2 times 2 times 1 is equals to 30. So, example number 2, gamma of 3, gamma of 2.5 over gamma of 5.5 is equals to the, since we have a formula of gamma of n is equals to n minus 1 factorial. So, gamma of 3 is equals to 2 factorial. Gamma of 2.5 is equals to 2.5 minus 1. So, 1.5 times 0.5 gamma of 0.5 then over gamma of 5.5 is equals to minus 1. 5.5 minus 1 is 4.5 minus 1. 3.5 minus 1 is 2.5 minus 1 is 1.5 minus 1 is 0.5 and gamma of 0.5 it is equals to 16 over 35. Then example number 3 is 6 gamma of 8 to the third over 5 gamma of 2 to the third. So since yung 6 ay hindi siya naka-gamma, so ilalagay lang natin 6. So gamma of 8 to the third is, so 8 to the third minus 1 is 5 over 3. Minus 1 is 2/3. And then gamma of 2/3 over, so 5, hindi siya naka-gamma. So, rewrite lang 5 gamma of 2/3. So, it is equals to 4/3. So, let's have an example number, wait lang, lalaki lang natin nod. So, number 4. So, number 4 is evaluate the integral. So, this is integral from 0 to infinity x raised to third power e raised to negative x dx. So, Rn is equals to integral from 0 to infinity. So, general formula, so e raised to negative x raised to n minus 1 dx. So, dito sa may example natin dito, makikita natin yung x raised to n minus 1 is x raised to third. So, n minus 1 is equals to 3. So, ito yan. So, we are going to finding n. So, ang n is equals to 3 plus 1 is equals to 4. So, we are going to integral from 0 to infinity So integral 0 from infinity to infinity, 0 to infinity, x raised to the third e minus x dx is equals to gamma of 4. Since alam naman natin na itong x minus x raised to negative x n minus 1 is equals to gamma of n. So, ang hinahanap lang natin dito is yung value ng n. So, since ang value ng n natin is 4, so gamma of 4. So, it is equals to 3 factorial. So, it is equals to 6. So, that's it. So, example number 5. Integral from 0 to infinity x raised to 6 e raised to negative 2x dx. So let 2x is equals to y. Then the integral becomes let x and let 2x is equals to y. So 2y. So from letting the integral so we are going to integral this. So we will have integral from 0 to infinity y over 2 raised to 6. So e raised to negative y dy over 2. So it is equals to, if we integrate this, so we are having 1 over 2 raised to 7 integral from 0 to infinity y raised to 6 e raised to negative y dy. So since this is example like number 4, so we are going to know the value of n. So here we are going to get the value of n or the gamma. So y raised to 6 is equals to n minus 1. So we are going to find n. So 1 plus 6 is equals to 7. So the value of n is equals to 7 since this formula is equals to the gamma. So integral 0 to infinity y raised to 6 negative e raised to negative y dy is equals to gamma of 7. So this will become gamma of 7 times 1. So gamma of 7 over 2 raised to 7. So gamma of 7 is we know that this is equals to factorial of 6 over 2 raised to 7. So it is equals to the answer 45 is equals 45 over 8. So that's it for the gamma functions. So I hope that you already get the gamma functions.